In this example, we're asked to find the area of the region bounded by the curve given by r equals 9 cosine 4 theta on the closed interval from 0 to 2 pi radians. To find the area bounded by a polar curve, we use the formula area equals 1/2 times the integral of r squared integrated with respect to theta from alpha to beta. So we do have all the information we need in order to find the area, but I do want to show how this curve is traced over the closed interval so we can determine exactly what area we're finding. And we'll do this using the graphing calculator, and we'll do this in degrees rather than radians. So let's press the mode key, make sure the calculator is in degree mode as well as polar mode as we see here, and we'll press y equals. I've already typed in the equation r equals 9 cosine 4 theta. But before we graph this, we do want to make sure we have the window set correctly. So let's press the window key. And again, we're using degrees, not radians. So we want the theta minimum to be 0 degrees, the theta maximum to be 360 degrees, and increments of theta would be by 5 degrees. Let's change the interval for x from -10 to +10. And I think the y values are already from -10 to +10, which they are. Now let's press graph. Now we have a pretty good graph of our polar curve, but we do want to square the window so that the graph is proportional. So let's press zoom option 5 for square. And now the graph looks exactly as it should. So now if we press trace, we can see how much of the curve and in what direction the curve is traced as theta increases from 0 to 360 degrees. So notice at 0 degrees, the point is here at the point 9, 0, and as theta increases, the curve is traced in this direction. And this is how we would accumulate the area as we integrate from 0 to 2 pi radians, or from 0 to 360 degrees. So notice as we approach 360 degrees, we're approaching the original point we started at the point 9, 0, which means over this closed interval, we trace the entire curve, and therefore the area that we're finding would be the area of all 8 petals, which would be the area of the shaded region here. So we'd have the area equals 1/2 times the integral of r squared, which would be 9 cosine 4 theta squared d theta, and again the interval is from 0 to 2 pi radians. Now let's go ahead and square 9 cosine 4 theta. Well, 9 squared is 81. So if we factor the 81 out, we'd have 81 halves cosine squared 4 theta. Now from here, we'll have to apply a power reducing formula since we don't have an integration formula for a cosine squared u. So looking at the formula given here below, notice how cosine squared x equals 1/2 times the quantity 1 plus cosine 2x. So when performing this substitution, we double the angle. And notice how we have this factor of 1/2. 1/2 times 81 halves would be 81 fourths. So this is equal to 81 fourths times the integral of the quantity 1 plus cosine 8 theta, which is 2 times 4 theta. And now to find the antiderivative of cosine 8 theta, we do have to perform u substitution, where we'd have u equals 8 theta, and therefore differential u equals 8 d theta. Dividing both sides by 8, notice that 1/8 du equals d theta, which means we'll have an extra factor of 1/8 when we find the antiderivative of cosine 8 theta. The antiderivative of 1 with respect to theta would be theta, plus the antiderivative of cosine 8 theta would be 1/8 sine 8 theta, so we would have 81 fourths times, when theta is 2 pi, we'd have 2 pi plus 1/8 sine 8 times 2 pi, that's 16 pi, minus when theta is 0, we'd have 0 plus 1/8 sine 0. Well, sine 16 pi would be 0, so this product is 0. Of course, that's 0, and sine 0 is also 0. So this works out nicely to 81 over 4 times 2 pi over 1. Simplifying, the exact area would be 81 pi halves square units. Let's also get a decimal approximation for this value. So we have 81 pi divided by 2, which is approximately 127.2345. But because we have a graphing calculator, let's go and check our work by evaluating the original definite integral. But before we do this, we need to remember to change the calculator back to radian mode. So we'll press the mode key, go down to row 3, highlight radian, go back to the home screen, and we'll enter 0.5 for 1/2, and then math 9 brings up the integral. The lower limit of integration is 0, right arrow. Upper limit of integration is 2 pi. Right arrow. The integrand was, in parentheses, we have 9 cosine 4 theta, close parenthesis for the angle, close parenthesis for 9 cosine 4 theta, squared. Right arrow. The variable of integration is theta, and enter. And notice how this verifies that our work is correct. Again, we have the exact area here in square units, and the approximate area here, again, which would be square units. I hope you found this helpful.